This is problem 5B on the practice problems for test number 2. A square parcel of land measures 2 miles on a side. Curtis decides to walk directly from one corner of the parcel to the opposite corner. How far does he walk? Round your answer to the nearest hundredth of a mile. So we'll start here by drawing this square parcel of land. It says that the land measures 2 miles on a side, so we'll put a couple of 2's. And then we're going to walk directly from one corner of the parcel to the other. And the question is, how far did we walk? So how about we give a name to this thing? Let's call that x. And so I'll just be clear here and say let x equal the distance Curtis walked. And this is going to be measured in miles, the same thing the 2's are measured in. So how are we going to solve for x? Well, we had a square, but then we cut it in half by drawing the diagonal. And so that means we have 2 triangles. These aren't any 2 triangles, these are special triangles. Because it's a square, we know that the angles are all 90 degrees, otherwise known as right angles. So that triangle up there in the top left is a right triangle. And we also have 2 sides, 2 lengths of the sides of the right triangle. And we're looking for the third side of the right triangle. So let me just go ahead and highlight that triangle here. This is the one I'm talking about. That right triangle, we know that we have 2 sides, and we're looking for the third side. And there's a real famous theorem, perhaps the most famous theorem in all of mathematics, that tells you exactly how to find the third side of a right triangle given the other 2. And that's the Pythagorean theorem. Okay, so many folks know the conclusion of the Pythagorean theorem, but let's go ahead and just draw a quick picture here for the Pythagorean theorem. Right triangle, A, B, and C are the sides of the right triangle, but they can't just go anywhere. C is always the one that's opposite the right angle. So if we have that picture, then the Pythagorean theorem tells us that A squared plus B squared is C squared. So let's see if we can translate that picture of the black triangle up into the green triangle that we're focused on in the top left. So in the green triangle, we have a 2 and a 2 on the 2 sides that were labeled A and B. So this becomes 2 squared plus, and this is also 2 squared, equals, and then we don't have C in our picture, but what letter do we have where the C is supposed to be? We have an X, so that's an X squared. And now we can leave the pictures behind and just focus on this equation, do some algebra here. 2 squared is 4, plus another 4 is x squared. 8 is x squared. And then how do we solve that equation? Well, the opposite of taking a number and squaring it is square rooting it. So I'm going to copy this equation again, and then I'm going to put the square root symbol in front of both sides. Remember, whatever you do to one side of an equation, you do to the other. Okay, the square root of 8 is something we're going to type into a calculator. It's not a very nice number, so we'll just leave that here. The square root of x squared. Okay, I'm going to put x, but I'm going to ask you to pause and say, well, is it really x? There was some little nuance, a little detail that we talked about in class, that actually there's something missing, technically speaking. And that thing that's missing is the absolute value. So the square root of x squared is actually the absolute value of x. And what that means is that x isn't just the square root of 8, but x is actually plus or minus the square root of 8. But that little detail actually makes no difference in this problem because x, you can see in the picture, is a distance. It's a length. It's got to be positive. There's no way x is the negative square root of 8. So we're going to go ahead and reject this. Since x is a distance. So that means that our final answer in radical form is the square root of 8. We're going to type this into the calculator, so let's do that now. So square root of 8 should be something a little less than 3. And we get 2.8. Let's see what we're supposed to round to in this problem. Round your answer to the nearest hundredth. Okay, so nearest hundredth here, 2.8, and then it's the 2 that we're focused on because that's in the hundredth spot. So that means we look at the next digit. That 8 tells us to take this 2 and go up. So it goes to 2.83. So it turns out on that diagonal, Curtis ends up walking 2.83, about 2.83 miles.